The Piocreat G5 3D printer just arrived fresh off the boat. The rough dimensions, including the crate here, are 34 by 40 by 21 inches, and the weight with the crate is about 140 pounds. We're here bright and early. I'm going to start building this thing. One thing to note is some of the metal on this thing is pretty sharp, so wear gloves and start opening the box. Alright, here's the first look inside. I removed a couple of these foam pieces here. You can see the frame. Some pellets are included, which is nice. A little bit of tape, some tools. Here's the next layer down. I removed some more foam. Here's the extruder, the tube that connects the extruder to the hopper, it looks like. Here's an instruction manual. Looks like a pretty nice machine just looking at it. The build plate looks really pretty nice. Here are all the parts fresh out of the box. It's a lot simpler than I was expecting, which is good. The two main parts are here. This is the lower piece with the bed, and then here. And they'll have to be connected. Some pellets, the screen, some other tools, tube, power cable, manual. This FGF stands for Fused Granulate Fabrication. It's essentially the same thing as FDM, except we're using pellets, but really it's very similar. Alright, let's go. Before I go too far into this, I'm going to talk about some things I like. Just the general look of this thing, I like. I mean, this is a pretty looking bed, well designed, and these belts are, I like how these have these belt tighteners here, tensioners, so you can tension the belts. These belts are already tight, but you know, I like that this is a big bed. This is a 20-inch by 20-inch bed here, so I definitely like that. And the sticker is peeling off, so that could be improved. I like that this comes with the tools and extra materials that you need to put this together. Even spare nozzles here, and a little BL touchpad. The first step here is to connect this tube from the hopper down to the nozzle. And it looks like we're going to use M3 8x2 screws. One thing you can do to speed some of this up is get a set of these hex keys or Allen keys. These all have a ball end here, so it makes it real nice to get the screws. This is an M2.5 and was used to secure these. Now this is the hopper here, kind of interesting. This is all lubricated here to be able to swivel. So there's like this, almost like a Vaseline right in here at the bottom. There's two connecting pieces here. Kind of interesting. I haven't seen that before. Alright, one instruction I don't really understand is here. You have these three holes here, and this is the screen bracket. This is supposed to attach here, but I only see one tapped hole with this screw. I just put this screw in it. So, you know, you look here, and there's three screws, and the bracket's supposed to attach on, but I only see one hole. So I'll just put like one screw through here for now, but it's gonna kind of move like this because I don't see three tapped holes. These two wheels here fell off during shipping, so I was going to connect this here to here using the screw holes. Put this on the side, and then this whole table came out here because of these. These are missing. So in the future it would improve their shipping if they put these on and put a piece of tape on, and then in the instructions told the user to remove the tape, just so these don't fall off. It just makes things easier. I had to take the screen off down here. What I'm doing is tilting this on the side. Here's the screen. And then I'm going to connect this with the M4 bolts. Here, there's four of them. 1, 2, and then on the other side, another 2. The next step is adding these pull rods here. And this is for structural rigidity, so this won't move back and forth. when the y-axis moves. Next up is the wiring. It's pretty straightforward. You want to connect this green connector and all the other ribbon connectors. You have to remove a couple screws to get into here. But you know, you connect the ribbon connectors. Also Z1 here for the Z-axis on this NEMA 17 motor, and then Z2 is down there. So there's two Z-axis motors. They have to be connected, all the limit switches, and so on and so forth. It's not too complicated. Just for fun, I decided to remove this panel down at the bottom because here is a little document showing the board in the manual. And just to peek inside, here's what we have. We have the power supply, and then we're connected. This adjusts the input voltage to the machine. We go to the power supply. Here's the control board. So eventually all the thermistors, stepper signals, so on and so forth, it all terminates here. And then we have a couple stepper drivers here. This is for Z, this is a stepper driver for Z, and then down here is a stepper driver for Y. Alright, just for fun, I took the cover off here, off of the extruder, and there's a little board here and a little control knob. One thing to check is the height here on either side, up to from the base up to the x-axis, and you want to make sure those are the same. That can be adjusted by undoing these screws and then retightening them. Oh, this is exciting. I just turned the machine on for the first time. I was wrong about this. This knob is actually for the fan speed. You can hear it, the fans kick in more when I turn it up, and they'll go down when I turn it down. Anyway, so this is all in Chinese here. I need to figure out how to get this into English. There we go. Okay. So you go from settings, and then it's this second to last one down. Right here. Alright, while we're at it, let's move the Z-axis up so we can get into the, tighten this up. One thing that's kind of neat is this whole assembly, this whole frame with the hopper and everything, this all goes up. This is all connected here. So when I press Z, go for this to go up, this whole thing raises with the hopper and everything. It's pretty neat. You're going to need a lot of clearance in regard to the total height of the machine. We're a couple hours in. I took a couple breaks for like 20 minutes and also showed you some things like the control board, which was an extra 10-20 minutes. So someone experienced in building these could probably do this quicker, but it's taken me about 2.5 hours so far. The axes, the XYZ all move. And X. And then off to test the extruder. I'm not sure if cold extrusion is allowed or if I have to heat up the extruder, but we'll see. See, there's a fair amount of play in this. As I lift this up, it'll really jiggle around. So to change this on this lower wheel, put a wrench in here, and then use this behind the wheel. There's an eccentric nut, and this will tighten down onto this rail, and then after it's done, it should wiggle a lot less. Kind of interesting to note as well, here's like a BL touch for bed leveling. Alright, I removed this plate and the 4 screws holding it because I wanted to get to this insulating shroud here. It's hanging down really low so far, that so low it's going to block the nozzle and interfere with parts. So I'm going to try to lift this up so it doesn't interfere with the nozzle as much. Because right now the nozzle's hanging down here, and then this shroud is going to hit any kind of layer that's deposited. You can see here, here's the heating element, and then behind it is the thermistor. This is all tightened up now as well. That eccentric nut down here did the trick. Alright, I lifted this insulating shroud up about ½ an inch, and now the nozzle's clearly sticking down. And also the BL Touch back here can hit the bed too freely. Just for fun, I removed where the pellets enter the extruder. Pretty neat looking extruder here. You can see this is a machine block of aluminum right in here. You can even see the marks from where it was milled. And then the extruder, you can see the screw. And it's going into this kind of like a copper area where the pellets are heated and melted. Very neat looking. The copper is going to help with melting those pellets quickly. Let's see if we can do a cold extrusion here. What I'm going to do is go to the menu and let's see, move, load pellet. Let's see what happens if we do a feed. I'm going to feed 20 and we're going to give it a shot. And there's also the fast or slow. We're going to do normal feed 20. Let's see what happens. Alright, this is kind of interesting. I went to test the extruder by going to move, then load pellet, then feed 20 here. We have different speeds to extrude. I did this feed 20, and it doesn't allow cold extrusion. It'll heat up. It takes about 2 minutes to heat the nozzle, and then it'll feed. Here we go. One nice thing about this machine is it does come with PLA granules here. So what I'm going to do is I'm going to take this, I'm going to pour it into the hopper for a little test here. We're going to see if we can do a little manual extrusion. I like this hopper. I think it's neat. Flips up like that. We're going to take this, pour it in. There they go. There they go. All heated up here, the bed and the nozzle. I changed this to 100 instead of 20. So hopefully that's more like a full rotation. I can go back and look at the video and see, you know, how much 20 did, but it looked like about a fifth of rotation, but I could be off on that. So I'm going to keep hitting feed here until something comes out. I also heated the bed. I'm really impressed with this bed. I mean, it's a really big one, and it's at a 65C. It took a couple minutes, but yeah, it's nice. Alright, we got stuff coming out. That's good. That's real good. Alright, it took 4 of these rotations. I pressed feed 4 times fast in this fast mode here, and so somewhere around 4 rotations, and we're getting PLA coming out, oozing out. Very good. Alright, I just went to auto bed level it, and I got this error. For whatever reason, the auto leveling isn't working, so I'm using this traditional paper method. Wiggling the paper under the nozzle till I feel resistance. And then I'm using these 2 adjusting knobs here to adjust the height of the nozzle. Here is the manual adjust leveling. Alright, I press the auto leveling feature and then measuring, and it's going to automatically test. Right now we're lowering Z. And it's going to use the little BL Touch. It took about 3 minutes and it tested 32 points here. Alright, we're going to go for our first print. We're here in Simplify 3D. I created a new process and changed the size of the printer, so on and so forth. And here's where you adjust the printer size. And we're going to go for 0.8 millimeter nozzle diameter, 0.4 layer height, 100% infill, yada yada yada. This is saved to an SD card. And we're going to start with this 1-inch test. And then we're going to go to a bigger test. So we put the SD card in here. And it's heating up, and we'll see what happens. So, first print attempt. What's going to happen here?
Alright. Oh, that nozzle's awfully high. We're going to have to offset the Z offset there.
Okay, I had to adjust the Z offset a lot, over a millimeter lower. But it looks like it's working. Alright, here we go. First print, hot off the printer. Took 6 minutes, and this is it. I'm going for a 10-inch test cube now. The 1-inch worked just fine. The Z offset I did lower even lower, but it's working, and it holds this value even if I turn the machine off and turn it back on again. Moving slightly faster now on the second layer. Usually that's how it is anyway. The first layer is the slowest. Let's do print speed 200. Moving now. Let's see how fast we can push it. 400. Alright, lowered the Z offset to get better adherence on that first layer. 400% printing speed. We're moving along. Filament is sticking. How fast can we push it? Let's see here. There we go. We tried 400% printing speed, and the X-axis did not like it. At a certain point it got here, and then it more or less stalled out, and then froze up in X. So that's too much. In total, the entire bag went into here. This was about a 4.5 pound bag, and it fills the hopper and the tube. So I bet you could get about 5 pounds of PLA in this thing total. So a little over 2 kilograms. Alright, this printed in 35 minutes using 200% speed. Let's see what 300% does. Alright, at 300%, we finished in 33 minutes. I think this is about the fastest it'll go without the X-axis stalling. This is a typical nozzle for a printer here. It has a thread on the end, which is M6x1. Now, the nozzles that fit on this Piocreat G5 printer are bigger. You can see here the thread is larger. This is actually an M8x1.25 thread. Now, just for fun, what I'm going to do is these are the 2 spare nozzles that come with the printer. Here's a 1mm. And here's a 0.8 millimeter. I'm going to bore this one out using this drill bit to 2 millimeters and see if I can get it to lay out 1 millimeter layer heights on the same test square as before. Here we go, 10-inch test square, 1 millimeter layer height. This is the normal speed. Let's see what happens. Let's see what happens if we turn up the speed from this normal speed here to I adjusted this. I had to adjust this for the larger nozzle. Let's go to 300. Whoa. Okay. Oh, it's really grinding. It's too much for it. Too much. Let's turn it back down here. Let's go to 200. Okay, we're at 200 now. 300 is too much with that big layer height. 200 it's seeming to be able to handle. Yeah, that stepper, I can hear it kind of stalling a little bit, but it's still squeezing it out. Oh yeah, I hear the stalls. So I guess we'll stick with around 100. We're at the 200 right now. Oh, I hear the stepper stalls. Alright, we're going to turn it down. Let's go to 150. Alright, turn it down. Here we go. Alright, I'm not hearing any extruder stepper stalls. We're cruising now. Nice. Alright, this is probably the max speed I would go here. Alright, the test square weighs 25 grams. Took just over 6 minutes, so a little less than 250 grams per hour. And that's how much this can output. This pellet extruder can output with the 2mm nozzle on there. I bored that out to 2 millimeters. The max speed, I wouldn't run it more than at the 150 setting that was on here, and that works out to be about 1 inch per second or 25 millimeters per second. Above that, the extruder was really stalling quite a bit. This machine, when it's ready to use with 4 pounds of pellets, weighs about 90 pounds in total weight. Well, thank you for watching. This is a big machine. This is a big machine. It's about 28 inches wide, including the pendant, and then 29 inches deep here. But you have to take into account this bed will also go about 7 inches past the end on either side, so it'll go up to like 7 inches this way or 7 inches past the end here. And then the height, it's about 40 inches like this with the Z all the way down. But when the Z comes all the way up, add another 24 inches. So about 64 inches in total height if the Z is all the way up. So pretty big machine, 64 inches in height when the Z is fully up. Thank you for watching. I hope you find this useful. Happy pellet extruding, everybody.